Hi everyone, welcome back to this channel. In this quick video, I'm going to show you 3 things that you can do with the spectrum analyzer, especially when you are measuring a signal that is a wideband signal, such as what you're seeing on the screen right now. This is a digital modulated signal, and currently I'm using a 64 QAM signal with a bandwidth of about 4.2. These features that you're seeing right now on the screen is what we call the channel power measurements. So this is options, and it means that you have to purchase this. So we're going to do 2 types of measurements here. One is with the options, such as channel power, ACP, occupied bandwidth, and the other one, in the events where you do not have all these options in your spectrum analyzer, you can actually use the built-in marker to do the similar measurements. It's a bit tedious because you need to do more setup. You should get a very similar reading from there. The first one I want to do is to try to use the channel power, the built-in options, and go through that step by step. So we have a signal that's transmitting at 1 GHz. The occupied bandwidth is roughly about 4.2 MHz. So one way to check it is to use the marker. And as you might know, the definition of channel power is to measure the power that's occupied on a bandwidth. How do we determine the bandwidth? Is a 3 dB away from the top flat area in layman term. This is how we can do it. So on average, we are looking about minus 26 dBm. So we want to look for minus 3 dB point. So just drag this. Across this flat top, we are looking at minus 26. So minus 3 dB further down is about minus 29. So we can do it somewhere here, minus 29-ish. So with that in mind, we can go to measurement setup. This way you can change the integration bandwidth. So by changing that, let's say this 5 MHz is really too big. So this 3 MHz is really a bit too small. So we just want to do it's about 4.1. So as you can see, the lines is on top of that marker that we set up. So assuming that both left and right are symmetrical, so this is what we are seeing. I'm pumping out minus 10 dBm from the signal generator that's connected to this, and this is what we're looking for. If you do not want to do it manually, you can actually use the occupied bandwidth features. So how do we get there is go to spectrum analyzer, occupied bandwidth result. So this will automatically find the region of bandwidth that you should be seeing of the signal. And we do not have a way to set it at minus 3 dB, but we use another way to represent it. It's called the percentage of occupied bandwidth power. By default, it's 99%, and you can actually tweak around to make sure that it falls within that minus 3 dB range. How do you change that? Again, go to measurement setup. This is where I can change. So you can actually turn on the averaging just to stabilize the signal. Most of the time, users just use the occupied bandwidth value over here. This is 4.5 meg, and then we dump it over channel power here. So it's a bit different. Again, depends on how you define your occupied bandwidth to start with. Then you set the value over here. And then the third thing I want to do is the ACP. So I already preset this ACP to a few different subsequent channels for that, because there's no spec for this. So I just mock out spec as we are seeing here right now. So how do we set up the offset over here? Go to measurement setup. So the measurement setup is what we are seeing here. Then we can set up the offset. First of all, we want to make sure that it's one carrier. If you have multiple carrier, you can actually change the value here. Sometimes you have multiple channel at one go, and you want to test the amplifier, see how it responds. And this is where you want to change that. So once you have that carrier set up, so the other one I want to set is offset. So these are the subsequent channel that you want to test out. This is where you can set up the offset frequency, integration bandwidth. So this is one that we want to use, 4.2, and this was done earlier. So we change back to 4.1 as we set up, and 4.1 or so. And again, depends on the spec of your testing. This is where you going to change the value of offset. And on top of that, you can just set the limit so that at one glance you can see whether it's pass or fail. This is the limit line that you can change over here. So let's turn on that limit line. So as you can see, the relative limit line is over here. Any of the signal is above that line, you see one big fail sign on top of it. So that's enough for the install options. So it's very easy, and then quickly you can do the channel power measurements, occupied bandwidth, and ACP, adjacent channel power measurements, just by looking at it and then retrieve the data. So in the event where you do not have the options, you can actually use the marker options that's available. Going to start again from here. So at the marker, I will just change to normal, and let me change everything back to normal. So let's turn it off. So just to recap, the signal is at 1 GHz and the bandwidth is about 4.1 MHz. These are the subsequent channel that we want to test out later. So we go through one by one. Let's do occupied bandwidth measurement using marker function. So how do we turn on the marker? Let's go to here. Let's off first. So you go to marker 1. So by default, marker 1, once you click that, it will normally turn on. So this is normal, and then we can go to marker functions. So band functions, this is where you can use to measure certain integrated bandwidth measurements, just like the channel power measurements. So before we do any of the band power measurements, I would like to do a quick occupied bandwidth. I just want to see how far we need to set up at the -3 dB range. So instead of letting it going up and down, I'll do a single and marker 1. Let's go back to marker 1 setting. So this is -20.94. So I set out a delta, and I'll just drag and drop. So we're looking at -3 dB right now. So this is a range that we want to look at. So -2.5 to -3. So let's see, we try to do 4.1, 2.05, so let's see, -2.01, so it's about 2.5, so let's say -2.05, it's -4, it's way too far, so -2.04, 2.03, still too far. Let's restart again so that does change. We can go further down, 2.02. So it's roughly there, because every time you change it, the signal just up and down. So let's keep it as 2.02. So we know the delta 2.02, so the integrated bandwidth we are looking at left and right, so it's about 4.04. So then we would go back to normal, let it continue, and let's drag back this marker 1 back to 1 GHz so that it stays in the middle of the signal. And the next thing I want to do is to turn on the band power, and I'll set this 4.04. So as you can see, it's roughly -10 as what we want. So this is one of the ways that you can use to measure occupied bandwidth and also channel power. How about adjacent channel power? So the next thing we want to do is we turn on the marker. So marker 2, there are many ways to do it. So we can drag this to the offset. We're looking at an offset of 6 MHz. So dragging, we can just 94. And then with the same setup for band power. So we can do band power 4.04 MHz. You really want to see the DBC, how far it is from the carrier signal. So before that, let's turn on another marker. Let's turn on marker 3, turn it on, down, on normal. Let's say we do it on the left side first, then we can subsequently do on the right side. Functions, power, let's drag it to, so it's 988 meg, because the offset of double of 6 megahertz, so 4.04. So we have 3 data right now. So we want to see the difference in DBC. So we can turn on the marker table, just go to setting, marker table, and straight away you are able to see it. So with that, you're supposed to do the calculation yourself to find out the DBC, the difference between carrier to the side lobe. So what if we do something different in marker 4? So we start from there, set up the band power measurement first. Band power measurements 4.04, and then we do a delta instead of normal. So with that, we are able to drag this to, this is offset of 6 megahertz. So you straight away get a reading of the delta 6 megahertz. So this is the DBC. It compares from what you're measuring right now to the carrier, to that first point. So it's about minus 64 DBC, which is quite close to, so let's turn it to single. So which is quite close to this number. It's about 66 dB on channel 2. So you can do it the normal way, or you can do a delta measurement. So as I mentioned in the beginning, you might have the options installed which make your life easier, and you can just click and straight get the reading out. And if you do not have that option, you still can do some measurements. There's more setup step that you have to do before you get to the end result. So at the end of the day, the result is quite identical. I made a mistake. We shouldn't compare the reading over here. This is why at one point this function value, because right now we turn on the functions to band power, so it's 64 dB, which is quite identical to between 0.2 and so this delta 0.4. And let's recap back. The reading that you get from this marker band power, you should get similar reading to the options reading, so minus 10. So it depends on how you set the band power, the functions width. So in channel power, there are 2 reading here. One is dBm per hertz, because this is a raw data, and with that you are able to compute again on the total power across that bandwidth. So you can actually divide and then get this reading, or you can grab the reading from here straight away. So the function reading is over here, and we can add in another marker just to show you that we can read that dBm per hertz reading also. So again, turn on marker 6 and 1 gig. We do this marker noise. So 75.9 dBm per hertz. So that's a bit different because you need to find out the setup, whether you set it correctly, the bandwidth and whatnot. And hopefully this helps in the events where you need. So let's change that identical. So 76. So I hope this helped, and thanks for watching.